What do the following things have in common? The water traveling over this thundering waterfall, the vast sea of air as seen from this mountaintop, the metal in this fire truck, and these sea lions. All these things possess matter and take up space. Everything we see, and even some things we can't see, such as air, are made up of matter. Everything we touch, taste, and smell is made up of matter. Matter, such as flowers in this garden, take up space. In other words, matter is anything on Earth that has mass and volume. We'll talk more about these terms later. During the next few minutes, we're going to explore how some of the characteristics of matter can be measured. More specifically, we're going to see how we can use the metric system to measure some of the properties of matter. As we just mentioned, matter is anything on Earth that has mass and volume. What exactly are mass and volume? Let's start with mass. Mass is defined as the amount of matter in an object. This apple has mass, and this horse has mass. Water has mass. Our bodies also have mass, and believe it or not, the air we breathe has mass. Volume is different than mass. Volume is the amount of space something takes up. All the things we just mentioned have volume. You compare. What has more volume, this motorcycle or this car? That's right, the car has more volume because it takes up more space than the motorcycle. Even though mass and volume may seem similar, they're actually quite different from each other. An object, such as this stone, can have a relatively large mass because it contains a lot of matter. But its volume is relatively small because it doesn't take up much space. This beach ball, on the other hand, has little mass because it does not contain much matter, but it has a large volume because it takes up much more space than the stone. As you probably already know, in countries such as the United States and England, the system of measurement commonly used is the English system of measurement. Mass in the English system of measurement is measured in units of pounds or ounces. This is a 5-pound bag of sugar. The other system of measurement commonly used in most other countries and in science is the metric system. In the metric system, mass is measured in units such as grams, kilograms, and milligrams. Let's take a look at each one of these. In the English system, mass is commonly measured in pounds. However, in the metric system, body weight as well as foods are measured in kilograms. A kilogram is equivalent to about 2.2 pounds. This rock has a mass of 1 kilogram, and this amount of candy has a mass of 1 kilogram. 1 kilogram consists of 1,000 grams. This is a 1-gram mass. There are 1,000 of these in a kilogram. Smaller objects are measured in grams. This marble has a mass of about 20.5 grams, and this raisin has a mass of 0.5 grams. The masses of even smaller objects are measured in milligrams. A milligram is 1/1000th of a gram. You decide. How many milligrams are in a gram? That's right, there are 1,000 milligrams in a gram. So far, we've talked about the units of metric mass. But how is mass actually measured? One piece of equipment you may have in your science lab used to measure mass is a balance. There are several different kinds of balances, but they all work using the same principles. A balance works when an unknown mass, such as these chocolate chips, is balanced against a known mass. This type of balance is called a triple beam balance because there are three different beams or sets of weights. Weights are adjusted until the weights are balanced against the chocolate chips. You observe. What's the mass of the chocolate chips? That's right, the mass is 17.8 grams. This alligator takes up space. These large skyscrapers take up space. And these balloons also take up space. Anything that takes up space has volume. Volume is the amount of space an object takes up. In the metric system, liquid volume is measured in liters. This plastic bottle contains 1 liter of soda. There are 1,000 milliliters in a liter. A milliliter is a very small amount of liquid. When measuring the volume of smaller solids, metric units called cubic centimeters are used. This small cube is a cubic centimeter. It's 1 centimeter long by 1 centimeter high by 1 centimeter wide. This cardboard box, for example, has a volume of 27,900 cubic centimeters. The volume of gases, such as the air in this balloon, is often described in cubic centimeters as well. The volume of larger solids is measured in metric units of cubic meters. A cubic meter is 1 meter long by 1 meter high by 1 meter wide. It's relatively easy to measure the volume of liquids in the metric system if you have the right tools. When cooking, spoons and cups measure liquids in milliliters. This spoon, for example, contains 5 milliliters of molasses. In the science lab, the volume of liquids can be measured using tools such as beakers and graduated cylinders. This container is called a beaker. It holds up to 250 milliliters of liquid. You observe. Approximately how many milliliters of acid are in this beaker? That's right, there are about 150 milliliters of acid in the beaker. Graduated cylinders, such as this one, are often used to more precisely measure the volume of liquids. This small graduated cylinder is used to measure small amounts of liquids. The volume of regularly shaped solids can be calculated by measuring the length, height, and width of the object, and then multiplying the numbers. Let's compute the volume of this brick. It has a length of 18.8 centimeters, a height of 5.6 centimeters, and a width of 8.5 centimeters. When we multiply all three, we get a volume of 894.9 cubic centimeters. The approximate volume of objects that have a regular shape, such as books and even buildings, can be measured this way. But what about objects that have an irregular shape, such as this necklace? We need to use another process when finding the volume of irregularly shaped objects. The process of water displacement is often used to measure the volume of irregularly shaped objects. One way this can be done is by filling a graduated cylinder with water to a certain point, such as 50 milliliters, then placing the object in the water. See how the level rises to 53 milliliters. You compute. What's the volume of the necklace? The volume is computed by subtracting 50 milliliters from 53 milliliters to get a volume of 3 milliliters. 3 milliliters of water is equivalent to 3 cubic centimeters. Therefore, the volume of the necklace can be expressed as 3 cubic centimeters. You decide. What has more mass, this kilogram piece of marble or this kilogram of wood shavings? If you answered neither, then you're correct. They both have a mass of 1 kilogram. However, the volume of the wood shavings is much greater. Why? It has to do with something called density. Density is a measurement of how much mass is contained in a given volume of an object. Another way of putting this is that density is the amount of mass per unit volume. The density of objects in the metric system is measured in units of grams per cubic centimeter. Fresh water has a density of 1 gram per cubic centimeter. Objects that have a density of greater than 1 gram per cubic centimeter sink, and objects with a density of less than 1 gram per cubic centimeter float. Since we know that water has a density of 1 gram per cubic centimeter, how could we find out if a block of wood will float without placing it in water? We already discussed that density is the amount of mass per unit of volume. This can be expressed as a mathematical formula where density equals mass divided by volume. Therefore, if we know the mass and volume of the piece of wood, we can compute its density. Let's first obtain the mass of the block of wood by placing it on a triple beam balance. You can see that its mass is 44 grams. To compute its volume, we need to measure the length, height, and width. By multiplying all these measurements, we get a volume of 115 cubic centimeters. Next, all we have to do is divide the mass by the volume. The density of the wood is 0.38 grams per cubic centimeter. You decide. Based on this information, will the wood sink or float? The block of wood floats. It has a density of less than 1 gram per cubic centimeter, and therefore it floats. Objects with a density of greater than 1 gram per cubic centimeter sink. During the past few minutes, we've explored many of the interesting features of metric mass and volume. We began by learning that mass is the amount of matter in an object, and that volume is the amount of space something takes up. We then explored how mass in the metric system is measured in kilograms, grams, and milligrams. And we took a brief look at how mass can be calculated using a balance. Turning to volume, we discussed how everything we see has volume. In the metric system, liquid volume is measured in liters or milliliters. In the science lab, liquid volume can be measured using beakers or graduated cylinders. The volume of solids is measured in metric units of cubic centimeters or cubic meters. We explored how the volume of regularly shaped solids can be easily computed by multiplying the length, height, and width of an object. But the volume of irregularly shaped solids is a little more difficult to calculate, requiring a method such as water displacement. Last, we investigated the idea of density. Density is the amount of mass per unit volume. So, the next time you need to calculate the mass of an object, or figure out the volume of something, or compare the densities of objects, think about some of the things we discussed during the past few minutes. You just might think about the metric system a little differently. Fill in the correct word to complete the sentence. Good luck, and let's get started. Number 1. Mass is the amount of in an object. Number 2 is the amount of space something takes up. Number 3. 1 consists of 1,000 grams. Number 4. This piece of equipment is a Number 5. The basic metric unit of liquid volume is the Number 6. This small block is a centimeter. Number 7. This cylinder is used to measure liquids. Number 8. Water is used to calculate the volume of irregularly shaped objects. Number 9 is the amount of mass per unit volume. And number 10. Objects with a density of greater than 1 gram per cubic centimeter